Now we're going to look at what happens if a problem gives you the zeros and asks you to write the polynomial instead. So this will basically be working backwards to multiply all of the factors out. When you are given a list of zeros and told to write the polynomial, your first step is going to be to write each solution in factor form. So if they say 3 is a 0, then you would write x minus 3. If -2 is a 0, then you would write x plus 2 because you're subtracting a negative and the negatives cancel out. So for each 0 you're given, you write the factor form by doing x minus the 0, and then you're just going to be multiplying those factors out. So you need to distribute them carefully, watch your signs, and then combine like terms, and that should be it. If a problem gives you a leading coefficient, then they're just saying after you do all of your distributing and multiplying the terms out, they may say the leading coefficient should be a 3. So if you don't have a 3 in front of your biggest exponent for your variables, then you just need to take that number and multiply it by everything in your polynomial. So if the leading coefficient is 3, just multiply all of your terms by 3. If they give you a degree for the polynomial, you shouldn't really need to do anything with this, but basically that number is just telling you what your biggest exponent should be at the end. So if they say it's a degree 5 polynomial, then you should have an x to the 5th power as your biggest exponent in whatever your final answer is. So here's our first example, and I'm going to ignore the leading coefficient and the degree part because I actually use these pieces at the end of the problem. So I'm going to start off by saying for each 0 that I have, I need to write x minus that number. So I'm going to have x plus 4, since I'm subtracting a negative number, and x minus 1, and x minus 5. So 3 zeros means I have 3 factors. For distributing these out, it doesn't matter which two you multiply together first. You can do the first 2 factors or the last 2 factors or the outside factors if you want. Whatever is easiest to you is fine for now. I'll give you some hints later when we're dealing with complex numbers. So I'm just going to multiply x plus 4 times x minus 1 to begin this. So if you go through the distribution, you should get x squared. The outside product is negative x. The inside is 4x. So I'm just going to combine those at the same time. 4x minus x is 3x. And then for the last product, 4 times negative 1 is negative 4. So all I do is multiply the first 2 factors together. Just do them 2 at a time. Now I need to distribute this trinomial by this binomial. So I'm going to start with x squared and multiply it by everything in the second set of parentheses. So that's going to give me x cubed minus 5x squared. So I used everything in the binomial, so now I go to the next term. So now I'm going to do 3x times x and 3x times negative 5. And then negative 4 times x and negative 4 times negative 5. You should end up with some like terms that you can combine together. I don't have anything for the x cubed. That's the only like term. There are no like terms for the x cubed. For the squares, I see 2 of them. So if I combine these terms, I get negative 2x squared. For the x to the first power, I have negative 15 minus 4 more, so that's negative 19x. And then I'm adding 20. So based on the zeros, my answer is done. This is the polynomial that has zeros of negative 4, 1, and 5. Now I'm going to use this other information they've given me though. They said they want the leading coefficient to be a 2. And right now my leading coefficient is a 1. So I'm just going to take the entire polynomial I have and multiply everything by 2. That'll make the leading coefficient 2 for the x cubed. And then I just have to multiply everything else by 2 as well. I can't just multiply the one number, or I would end up changing my answer accidentally. So now I'm distributing the 2 through the entire expression. And the other piece of information I gave was that it has degree of 3 for our final answer. And sure enough, my exponent is a 3 on that expression. So this is the polynomial with leading coefficient 2, degree of 3. And if I solved this, if I went through the process of listing the possible roots, it would bring me backwards to negative 4, 1, and 5. So now let's look at what would be different if one of the zeros they gave us was a complex number or a number with an imaginary value in it. One of the important rules to know is that complex zeros always occur in conjugate pairs. So if they gave you a number like 2 plus 3i, then you need to know that 2 minus 3i is also one of the zeros of the polynomial. Now this is very important for these questions because they may only give you one of the complex zeros, and then you have to fill in the other one, the conjugate of it, yourself. So just make sure you understand conjugates, something like 3 plus I, the conjugate would be 3 minus I. The real number does not change signs, only the imaginary part changes from positive to negative. Other hints I'm going to give you here. After you set up your x minus the zeros step, when you're multiplying out your factors, always distribute the factors that have imaginary numbers first. So when we were doing it with all real numbers, I told you it doesn't really matter what you multiply. This will save you a lot of time and trouble if you multiply the imaginary ones together whenever you have those imaginary answers or complex answers that you're given. It's also important to know, for simplifying purposes, that I squared is equal to -1. So whenever you see an I squared, just replace it with -1, or basically just cross out the I squared and change the sign on that term so that then you can add it to some other number. If you are given the multiplicity for a factor on any of the solutions, that's just the exponent you put on the factor. So if they say 2 is a 0, then you would write x minus 2. And then if they say the multiplicity is 3, then you just put to the third power on that factor instead. So here's an example where we're writing the polynomial, and now we're starting to get some complex numbers for the zeros we use. So I start off by saying x minus each of the zeros we're given. And especially for the complex numbers, you might want to carefully use parentheses for this, because my complex number is 2 plus I. So use the parentheses to make sure that you distribute the negative through both parts of this number. Also, let me remind you, since I have a complex 0 here, it's important that we remember this rule I gave you. If they only gave you one of the complex zeros, you have to know that the conjugate is also a 0. So we need to fill in on our own that we have x minus, and then in parentheses, the conjugate of 2 plus I is 2 minus I. So that's what that first bullet was talking about. They may not give you all of the zeros. They may give you one of the complex ones. You have to fill in the other one on your own by knowing the conjugate. So to clean this up a little bit, I'm going to write this as x minus 1, and I want to distribute those negative signs. So it's going to be x minus 2 minus I and x minus 2 plus I. Okay, one of the other hints I gave you was for picking which of these polynomials to multiply together, you want to try and multiply the imaginary ones together first. So I'm going to leave the x minus 1 out front for now, and I'm going to do this trinomial times this trinomial. There is a lot of multiplying to do here, so you just have to be careful about your products. So I have x times x times -2, and x times I. So now I've taken the x and multiplied it by all three terms. Now I go to -2, and I multiply it all the way through. So -2 times x, -2 times -2, and -2 times I. And then I do this again. Now I have to take -I and multiply it by all three. So I get -xi, positive 2i, and -I squared. If you've done this correctly, there should be a lot of terms that end up canceling, like positive xi and negative xi, and also 2i minus 2i. And then there should be some other terms that we can combine. So for my next step, I have a single x squared. I have -2x, and then another -2x over here, so that's -4x. And then this is another piece to be careful about. I squared, I told you, is -1. So if you think of this as -1, I'm replacing the I squared with the -1 instead. This actually is the same as saying +1. So 4 plus 1 is 5. So if you've done this correctly, there aren't even any imaginary numbers left. They've all gotten canceled out, or we've replaced them whenever there's an I squared. So now I just have to do one more distribution. X times x squared, x times -4x, x times 5, and then -1 through. So -x squared, positive 4x, and -5. Some of those should be like terms again. So there's a lot of multiplying and adding to do on these. It is a rather tedious process when you have these imaginary numbers, but it's not that the operations are very difficult on their own. So I did negative 4x squared and negative x squared. Now I have 5x plus 4x. And then there's a negative 5 at the end. So that's the polynomial that, if we broke it down, would have the zeros of 1, 2 plus I, and 2 minus I. I wanted to do one last example with the imaginary numbers, and I wanted to show you multiplicities here. So this time when they say I have a 0 of 1, that means I need to write x minus 1 squared, or if you'd like to write that out as x minus 1, that's fine. And then my other 0 was I, so I have x minus I. This one is multiplicity 1, so it's to the first power, but it is a complex number. So the conjugate of I is negative I, which means I also have to include that factor on my own. Again, they only give me one of the imaginary numbers. You have to know the conjugate is also there. So for distributing in this case, since I have two terms here that I can multiply together, I can do it at the same time that I multiply these two binomials together. So x minus 1 times x minus 1 should give you this. If it helps, write out x minus 1 times x minus 1 and FOIL it. And then x minus I times x plus I is going to give you x squared. Now the outside product and the inside product will just cancel because you get plus xi minus xi. So I'm just going to leave that part off. And then you get minus I squared. Remember that this is equal to negative 1. So it's actually probably better to write that as x squared plus 1 instead. I'm replacing I squared with negative 1, so negative 1 is just a plus 1. So now I need to distribute one more time. So I have x squared times x squared and x squared times 1. And then negative 2x times x squared, negative 2x times 1. So just make sure you're multiplying every single combination of terms out. Combine the like terms. So here I have a positive x squared and a positive x squared, which adds up to 2x squared. And then I just have the minus 2x plus 1. There are no other like terms to combine on this case. So that's it. Just apply whatever multiplicity they give you as an exponent and carefully distribute and combine like terms. So now we have our final polynomial.